Today's daily code problem of the day is minimize maximum of products distributed to any store, number 2064. For this problem, we're given an integer n, indicating that there are n specialty retail stores. There are m product types of varying amounts, which are given as a zero-indexed integer array called quantities, where quantities of I represents the number of products of the ith product type. Our goal is to distribute all the products to the retail stores following these rules. A store can only be given at most one product type, but can be given any amount of that product. After distribution, each store will have been given some number of products, possibly 0 in some cases. We want to let x represent the maximum number of products given to any store. We want x to be as small as possible. So we want to minimize the maximum number of products that are going to be given to each store. Our goal is to return the minimum possible, or x. So the core idea is to tackle this problem, we need to make sure no store is overloaded with too many products. So we're going to use binary search to efficiently minimize the maximum number of units a store can get. And we can walk through this step by step. So first thing we're going to do is we're going to set up a binary search. And the reason we're going to use a binary search is it's going to be easy to minimize the maximum load a store has. So we are looking to prevent giving a store too many products, if that makes sense. So how do we do that? It's a very basic binary search. We're going to have an integer left equal to 0, and integer right equal to 0. And then we're going to find our maximum element in our quantities array. So for int q in our quantities. So for each element q in quantities, we're going to check if q is greater than our right value, which it should be since our right value is 0. If so, right will now equal our q. So we're simply looking for what the greatest quantity in quantities is, and then we're going to perform our binary search until our boundaries converge. So until our left and right variables converge. So while left is less than right, we're going to have our middle variable, very simple binary search, and it's going to be equal to left plus right minus left divided by 2. And we're going to call to a helper function here. Our helper function is going to distribute the products across our retail stores. We don't have to worry about that right now. We just know that's what we will do in the future, so we can call to can distribute. We're going to pass it our middle variable. We're going to pass it our quantities array and our n value. I'll go over that in just a second. So after we call to that function, if it returns true, we're going to equal our right to our middle variable. Otherwise, we will equal our left to our middle plus 1. And then at the end of this, once our while breaks, we can return our left variable. So what's going on here? We're using our binary search to minimize the maximum load any store has. So the left pointer is going to start at 0, and our right pointer is going to start at the largest quantity in our array. This is because our maximum load has to be between these two values. When we search for the minimum possible value of middle, our middle point, this lets us distribute all of our products fairly across the stores. All right, so after that, let's go ahead and look at our helper function can distribute. So what is can distribute going to do, and how is it going to do it? This function is going to check if we can distribute all products such that no store gets more than X units. So let's go ahead and do this code. So we're going to have a private, and it's going to return a Boolean called can distribute. It's going to receive an integer x, which is our middle variable, if you remember from above, an integer array called q, or our quantities, and an integer n, which comes from our input. Integer n is going to be the number of stores. So we're going to look to see what the minimum number we can distribute to each store is, and we will do that by using a pointer to traverse all of our products and see how many units we have to distribute. So we're going to have an integer j. We'll initiate to 0. That's going to be our pointer. And an integer remaining, which is going to start at q of j, or it's going to look at the remaining units to distribute in the jth position. Now we're going to loop through each store and distribute our products. So for each integer I is equal to 0, as long as I is less than our store amount, then I can increment. And we're going to check if our remaining is less than or equal to our middle value, or x, then we can increment j, meaning that there are still products remaining or exactly equal to our x variable. After incrementing j, we can check if j is equal to our q.length, meaning it's at the very end of our quantity array. We can return true, meaning that we can evenly distribute all of our products, allowing it to be minimized. Otherwise, our remaining is going to be equal to q of j, because that's however many products are left over. And it will cycle through again to try and distribute all the rest of the products. So if the first if statement doesn't even get hit, otherwise remaining is going to minus equal x, meaning that if remaining is not less than or equal to our x variable, we are going to subtract x amount from it, because that's how many we're going to get rid of. After that, we're going to return false, because we could not distribute all of the products evenly using the current middle value we selected. So if we go back up here and check out what happens, if it returns true, meaning we distributed all of our products evenly, allowing it to be minimized, then we can set our right value to middle, and it's going to continue to search until our left value is equal to our right value, meaning that there is no possible smaller combinations, and then we can return the left value. If there are smaller combinations, we will find those as we identify our middle variable. Otherwise, if canDistribute returns false, we are going to update our left to be middle plus 1, so that way we're looking for a greater value of x to distribute all the products. So we initialize our pointer to track which product we're distributing. We loop through the stores, and if the remaining units of current product type fit within our x variable, we can move to the next product. If not, we distribute x units until the current store and reduce our remaining account. And then we're going to return true or false if we can successfully distribute all of our units. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions. And check out my Instagram for a new Discord where I'm going to be sharing all my resources to learn.